conversation entitled Rehydrate Earth. My name is Damon Gamo. I've got the great privilege of hosting today's conversation, a conversation that really has been missing from a lot of the climate narrative, the role of the water cycle and how it can affect our temperatures on the planet, and provides incredible hope, actually, and incredible tangible opportunities for us to turn things around very, very quickly once we understand some of the concepts that you're going to hear today. I'd just like to start by acknowledging the First Nations people of this country that I live in Australia, and particularly their custodianship of the waterways of this country. Some of the early explorers, even in the early 1830s, a naturalist who was here named Dr. John Lotsky, reported that there were just these chain of ponds right across the landscape in Australia and really weren't seen anywhere else in the world. And yet just 15 years later, reports are written saying that the introduction of the sheep and the livestock had already caused soil erosion, gully erosion, the damaging of perennial grasses, and done enormous damage in a very short amount of time. And that element of destruction, the denuding of the landscape that we've seen in this country, is a big reason of why we're here today to discuss the impact that that's had on temperatures and why that's been missing from the conversation. I'm joined by two very esteemed guests who've got up very early in the morning to be here for this conversation. The first is Anastasia Markareva, and she's a senior researcher in the Theoretical Physics Division at the Petersburg Nuclear Physics Institute in Russia. She has a PhD in atmospheric physics and co-developed the concept of the biotic pump of atmospheric moisture, which we'll hear about today. And she has spent over 60 months conducting forest research in the Russian wilderness. So very grateful to have you here, Anastasia. Good morning. Mikhail Kravchik is our other guest. He is a multiple award-winning water management engineer. He's a hydrologist and author of the book New Water Paradigm. He's a water, drought and climate advisor for the Prime Ministers in the Slovak Republic and has lectured at many of the most prominent conferences in the world. So we really are joined by two of the world's very best when it comes to this conversation. A huge shout out to David Marr, who's not on this call today, but has been really influential in putting it together. Thank you, David, for your hard work. And to Bryony Edwards, who is feverishly behind the scenes working away at the slides and other sort of things that are going on to make this as smooth as possible. So I might start with both of you, Anastasia and Mikhail, just to give maybe a really quick overview, maybe 30 seconds or less, of what you hope the audience takes away from today. What's the key message that you hope they leave today's chat with? Anastasia, if you go first.
Okay, so my message would be that if we restore natural vegetation, it can change a lot. And by keeping water in landscape, natural vegetation can really transform even very dry climates to much more hospitable and favorable for human life. So we need to find this way how to coexist back with natural ecosystems.
Thank you. Yeah. And Mikhail?
Yeah, and my key message is that water is a fundamental food for all life. Life, from my point of view, is the citizens of the globe, together with biodiversity, vegetation, and so on. And all water on the nature, on the continents, is burning from rain. And we need to understand deeply that its rainwater is not waste, but it is gifts from God, which are starting new life for our sustainability is one, and second is about this key system for air conditioned system on the globe, and to make thermoregulation all continents, Australia, Europe, Asia, America, and so on.
Fantastic. So before we get pretty technical, because this stuff can get quite dense, I might just, there are two terms for the audience that we're going to hear a lot about today. So I might just give a quick overview. The first one is evapotranspiration, which some of you might not have heard of before. And basically that just describes the way that water is transferred from land or a water body into the atmosphere. It's just that process that happens. We're going to hear a lot about that today. And the other one we'll hear about is heat transfer. And the best example I can give of that is if you're holding a cold glass of water, there is a transfer of heat from your hand to the glass, not the other way around, that the heat naturally moves from warmer to cooler. And that's really important for what we're about to get into. So with that in mind, Mikhail, imagining that, you know, some of these people might be very, very new to this conversation, what is your clearest and simplest way that you would describe the water cycle of the planet?
And water cycle, if you are looking over this glass of water, which is quite full of water, but sometimes expert explain this is half full of this glass is water and half empty and so on. And from a new water paradigm principle, it is this glass is all time full. But sometimes this is condensated water, which we can see and we can drink. And another is evapotranspiration, which means it is extremely important is to harvest every drop of rain to the ecosystem, helping to saturate to ground, to soil, because it is biological and chemical processing is starting from humidity and production of new water sources in underground. And extremely important, it is starting to process for photosynthesis. And with photosynthesis, which means it is growing of vegetation, biomass, and water vapor to atmosphere and consumption of solar energy and transport to colder zones, which means it is permanently recycling water and with water return to again to the system. And hydrological experts still thinking that water which are vapor to atmosphere is lost. Water which are vapor is not lost. It is a background for new rain and new life which are coming to our ecosystem.
Brilliant. Anastasia, do you want to add to that?
Yes, and as Michael mentioned, this evapotranspiration, which is at the core of the water cycle on land, is very important, and it is coupled to photosynthesis. And when the leaf stomata, the small openings in leaves, open to catch a CO2 molecule, so a lot of water vapor comes out from inside the moist inner environment of the leaf. And so for each CO2 molecule caught, there can be several hundred water vapor molecules that go out. So it is a very powerful process which claims a significant part of solar energy. So to follow this process is very important and to pay attention to it, as we should see.
Yeah.
Yeah, and maybe it's for understanding, it's each cube, 1,000 liter of water, it is produced of biomass. And with biomass, it is eat CO2. CO2, it is using 1 kilogram for 1.4 kilogram of CO2 consumed for 1 kilogram of biomass, dry biomass. And for this, we need around 600 liter of water, which is important because where we can to start to reverse of carbon cycle, because it's, if you are looking over like Australia, we have a problem with desertification and loss of vegetation and very staying of CO2. CO2 is connect with carbon is connect with oxygen, and the result is this dangerous situation for increasing of CO2. And on the scientific community don't speak more around this interaction about influence of states of water on the nature, on the carbon cycle. But its carbon cycle means, from my point of view, CO2 is a keystone for life. And Anastasia say about this photosynthesis process, about molecule between H2O and CO2, and the result is this biomass together with solar energy.
Okay, we might get to that. So, if I was explaining this to my 5-year-old, I would say that the water cycle, it feels like it's just a big adventure that water goes on. And it starts in the land or in bodies of water or the ocean, and it gets evaporated. It might turn into the clouds, and then it comes back as rain or snow, and the cycle kind of starts again. Is that a very, very simple explanation? Probably too simple, but from my 5-year-old to grasp that, is that a fair enough overview?
What is important for the water cycle on land is that water runs down to the ocean. So it drains to the ocean because the continents are elevated. So we need to continuously move water vapor back from the ocean. Otherwise, land will go dry. So, and that's, as we will discuss, vegetation plays a very significant role in this atmospheric transport.
Right. So
for the ocean, for the ocean, it is simple. It is just evaporation and precipitation. But for land, it is more complicated because there is also runoff.
Right. So yeah, I wanted to get to that around. Maybe this is a good time to explain the difference between what latent heat is and what sensible heat is, and how that vegetation plays a huge role in what happens to that solar energy. And I guess this is almost the crux of today's conversation. This is the piece missing maybe from the climate discussion, is the role of how heat is trapped or disappears. So can you both maybe talk about this particular part, the difference between the latent and the sensible heat?
Yeah, and it's if we have a lot of water on the ecosystem, which means it's solar energy consumed on the vapor water to atmosphere. And due to law of saving energy, the solar energy is not lost. It is transformed to latent heat by vapor. And with vapor, it is transported with latent heat to colder zone in troposphere. And the result, it is, for example, if you are looking over the sky, we can see clouds, and after condensation of clouds starting rain, and this latent heat transformed to sensible heat.
Mm-hmm.
It is one. And second, if we are dry up and damage of landscape, and the result is the solar energy cannot consume of vapor water to atmosphere. It is job, real job. And after that is directly transformed to sensible heat on the ground. And the result is a heat bubble, and it is every cities, every damaged landscape starting to produce a lot of energy to atmosphere. And for example, if I today calculate some reality of Australia, it annually produce around 2 million terawatt hours of transforms to solar energy to sensible heat. It is huge, massive heat islands, which are moderate of climate system and to moderate of burning new rain and so on. And this is about problem to understanding, because we need more vapor water to atmosphere. I read some article from Africa about cutting of trees because it's pumping of water by evapotranspiration, and my community need of water. This is about misunderstanding, a lot of misunderstanding, which we need to deeply understand how to repair whole system and to change of decreasing of sensible heat production and increase of latent heat production by vapor water to atmosphere. Around this is photosynthesis, vegetation, and food production too.
So can I just clarify that, just Michael, so I can understand it in my head what you're saying there, because I think this is quite a tricky one. It is, if there's denuded ground and it's been degraded and there's not much vegetation, the sun that comes in and heats up that that surface, that's the sensible heat, that is going to get trapped in the atmosphere more by the carbon. But if we put vegetation on the ground, that solar heat that comes in, that gets evapotranspirated and comes, because heat moves from warmer to cooler, it gets taken out of the atmosphere and off into space, thus trapping less heat and creating more cooling. Is that a very crude summary?
Yeah, and it's because it's on the sky, it is clouds. And
Yep.
first effect about to decreasing of radiation from sun, it is clouds. And this energy is lost and coming to our ground. And we need to have, for example, food production or water resources we need for our life. And which mean it is, and together with air condition system, to make cool effect, which means we need more water on the system because this water follow down from sky and to absorb to soil and again to evaporate, which means many time and in small water cycle, usually it is recycling every 8 days, but I need to have water on the system. It's a big water cycle. It is recycling on the ocean around 3 months, which means it is long term, and it is results. Why is this prolonged period without rain? Because it's problem about desertification and lost water from small water cycles.
Okay. Anastasia, did you want to add anything to that in terms of that explanation?
Yes, regarding your explanation, you are perfectly right that Michal mentioned clouds that reflect sunlight and make cooling, and this is a very important effect. But what you mentioned is a very important also, that this energy that is captured as light and heat. And what is this energy? When the sun hits bare ground, it just makes the ground warmer, meaning that the molecules begin to move more quickly. But when there is water and evapotranspiration, this energy is spent to pull the water vapor molecule out from the water, where all molecules sit tightly together and keep each other. So to draw it away, you need energy, and this energy is latent heat.
Okay.
So, and then it is become like hidden in water vapor, and it moves upwards. And so most absorbers, like you mentioned, CO2 molecules are beneath, and then it condenses. And from that level, which is about 5 kilometers in the tropics on average, mean condensation height, the air warms, and the warmer air radiates more directly to space. So this radiation, which ultimately forms, escapes being redirected back to the surface. And this produces the cooling, the global cooling effect from the more intense water cycle.
Wow.
Besides the clouds, which is a separate thing.
Yeah, and for understanding, I was in 14 years ago in Canberra, and you can go to visit of a botanic garden and to understand deeply how is this thermoregulation by water on the system. If you go outside on the urban zone, this is completely overheat. This is about problem to understand, and this for many space, and to how to involve this process on the urban planning process is extremely important to manage of rainwater on the system.
Yeah. I think it's about an 11-degree difference in Canberra, somewhere between where they've repaired it and not. It makes me think of Australia there, Mikhail, and I mean everywhere in the world where we've just destroyed landscapes, and even seeing the temperature, how big the difference can be between a dry bit of land compared to some vegetation, like up to 30 or 40 degrees in some parts, maybe even more in Australia. Can you maybe just talk about Australia in particular, and how we obviously have destroyed so much of our landscapes, but that heat that is coming off the country, how does that contribute to some of the climatic events we've seen, the sort of huge rain bombs, or the huge the storms we've had? what contribution is that heat from the middle of Australia having as an impact on this country?
Yeah, and it's look above with this picture. It is thermal picture from 19 January this year, and in Sydney time and zone it's 4 p.m. It's graduate of heat on the whole territory of Australia. It is more than 60 degrees in inside. And this is extremely important to understand. And this heat bubble stop to inflow of humid air from ocean to inside. And the result is no rain. And with no rain, which means it is more overheat. And we need to make cool effect, and how to starting this process is extremely important, and we will be speak later how to decide with this model, because it's for example it's in January was massive heavy storm in Queensland, and the result is with raining was about 700 millimeters, and the result it is very small place. And question is how to decide it to change and to create condition for wider space for creation of not only clouds but rain and return water to the system. And this is concrete example about the situation, which how is burning of clouds around coastal zones, and with clouds and with humid air, it's not inflow to continental zones, and the result is more and more not only dry but overheat, and we need to deeply understand and how to change of whole position and to return rain to the system.
And would that also be affecting in Australia the obviously the excess heat? The oceans hold a lot of that heat. Would that impact of Australia and the heat that's coming off there, would that also be contributing to the damage we're seeing on the Great Barrier Reef? Would that be playing a role?
Yeah, I think it's a more overheat of ecosystem. I have some data about Sahara Desert, and last 50 years was increased temperatures 8 degrees. It is abnormal situation. It is more huge, massive heat island, and the result is this energy due to second thermodynamic view. Its flow from continent to outside, which mean to coral sea, to Pacific, Indian ocean, and so on. This is about problem to how to change and reverse, and we need to decrease of production of sensible heat and starting to make cool effect with better condition to decreasing of flow of energy in the troposphere from heat bubble.
Yeah. Yeah, and I think for those people that don't know, there'll be someone here that obviously know this very well, but obviously Australia, we've just done such horrific damage to our landscapes, largely because of agricultural expansion. And as I said before, we used to have incredible amount of chain and ponds and wetlands, and with the introduction of these hard-hoofed animals, I think we've lost 96% now of our wetlands, 96% throughout the country, 750,000 in the Murray-Darling Basin alone. So you think about what enormous impact that has had on water, flooding, all sorts of impacts to this country, and just drying out the central part of Australia. So it's a big part of our personal story. Anastasia, do you want to talk about how this has happened on a global scale? I know a lot of your work revolves around forests and the nature of how they work and the evapotranspiration that the forests do. Can you talk about what we've done globally that's led to this impact of temperatures?
Yes, for example, how we can decide that vegetation plays a significant role in global temperatures is from what happened in recent 2 years with the anomalous warming in 2023. And if we look at what caused that warming, and people recognize and researchers recognize that it is still a mystery, but clouds have played a role. And if we look where clouds declined in 2023, it will be over the biggest forests, like over the Amazon and Congo forests, and also in Canada, following those huge wildfires. So, and we know with the Amazon forest that during the recent years under Bolsonaro, when he was president, there was a huge spike in deforestation, and probably what we are seeing now is the reaction of the forest, which didn't quite keep, and now there is this disruption of water vapor transport from the ocean, and this leads to very large scale changes in atmospheric circulation and in the cloud cover. So basically we can see it now, having all the satellite data and being able, maybe for the first time in human history, to look at the Earth as a whole. So we are having this information about how important these processes are, and the natural vegetation and forests in particular.
Can you explain from your research what the biotic pump is and how that works?
Yes, if possible, the previous slide, if you could show with the water cycle. So basically what Michal mentioned, this problem when some people say we need our water and begin to cut trees, because trees transpire, and so the runoff decreases. So the biotic pump explains why this is like not the case when the restoration is properly done. So here on the slide you can see the water cycle as it goes. So there is evaporation of moisture from the ocean, which is then drawn to land, and the air ascends and it precipitates. And there is, when there is a forest, a functional forest or other natural vegetation, it transpires and keeps the atmosphere moist. And the moist atmosphere has a totally different dynamics than a dry atmosphere. In particular, there is condensation initiated, which wouldn't occur if the temperatures are very high and humidity is low. So it is important to keep it cool also, which is also achieved by transpiration. So when condensation happens and precipitation removes condensed water from the atmosphere, the pressure drops. Like the pressure where we are is equal to the weight of everything that is above us, of the gas above us. And when there is condensation and something is removed, the pressure drops. And this causes pressure gradients that facilitate the motion of moist air to where condensation occurs. And if it occurs over the forest, so the moist air will move from the ocean to the forest. So but and you can see that there is this positive feedback, and there can also be a tipping point. So if we deforest and if we reduce the vegetation cover, so at a certain point the loop can be reversed, and now condensation will be predominantly over the ocean, and it will be stealing the remaining moisture from land. So our main problem and challenge is to avoid this tipping point. And when you are in this, when you are past this tipping point, then indeed you get into what we call the dry regime. And in this dry regime, trees will transpire. Like imagine that you put a tree in the center of Australia, which Michal showed, like it's 62. It will transpire, but it won't be able to initiate condensation, and everything will be all moisture will be stolen away by winds. And this is what those people in Africa are afraid of. They have already a very dry situation, and the trees there like transpire, but nothing happens. There's no return on this investment, right? So and that is why it is crucially important, as Michal will be telling, to keep moisture in landscape, to keep it cool, and to keep it close to the relative humidity as high as possible, such as condensation is initiated.
Mm. Thank you, Anastasia. That was fantastic. Michal, do you want to jump in there, and maybe we can start to move to some of the positive there of how do we start to repair these water cycles, particularly like in Australia, we've done so much damage. What are some of the first steps we can start to take to keep that water in the landscape?
Yeah, important is to create this condition for public policy. If we are looking on the Australia, and we need to starting to debate in globally and in national level and territorial level and continental level to which new generation of water law we need. It is first. And we just now still thinking with water which are we are protect water which we are see, and we need to protect water on the system of small water cycles, and which mean every ownership of lands it is responsible for rainwater harvesting. If you have property, for example, 1 acre with your beautiful house or castles, and you need to harvest rainwater on your property. And this is extremely important. This is public policy, which means it is necessary to create conditions because it's clear that we need forest economy, agricultural economy, and urban economy, and so on. And we need to create conditions for understanding every from us need to be responsible for harvest rainwater on the nature. This is important, and we are starting in Slovakia many times years ago, and to mobilize some people to building capacity for rainwater harvesting, different technique, different solution, and naive solution, and professional solution, and so on. And this is we have a quite beautiful nice study about these results is one, and second is about to just now in Slovakia, a lot of people speaking, oh, we need to harvest rainwater because just now is this very dangerous situation to loss of water and desertification. And for example, in winter time, just now we have not snow. This is about problem. And I still explain that we need to return water to the system, and after that we will be, in winter time snowing and so on. And this is concrete solution which was building in Slovakia around 100,000 in period 16 months on the government level in 2011, 2012. And it's quite nice story how to very simply to involve unemployment people to building of water retention measures to harvest rainwater and to stop prevention to flood, drought, and to increase biodiversity and better condition for air condition. And this place that we have in Slovakia, for example, in my city, and in summertime, it was on the parking place was 73 degrees. And outside from this place, where we make this system, which was completely damaged before, and just now it is temperature was in summer only 33 degrees. This is about impact. What is mean water? Water for to starting to growing of vegetation, biomass together with make cool effect. And it is new generation. I think it's just now around the globe. It is a lot of people thinking when how is important to rainwater harvesting, because one technology is about to restore of wetlands, another to repair of check dams in erosion valley, and another is about to how to harvest rainwater from urban zones, what is mean for make cool effect on the heat islands and so on. And this is big challenges everywhere. And if I am looking on Australia, it is really a big challenge to starting to reverse system, repair a whole to desert zone which for you are living only around coastal zones, because inside is overheat, and but it is challenge. And how it is work with system, it is really to starting, for example, from coastal zone, every year to systematically growing of condition for rainwater harvesting and to support to overgrow new vegetation and make cool effect, and to bring new humidity to inside territory which are just now completely dry.
Yeah, I mean, it's very obvious to anyone living in Australia how much water we do waste when it falls here. Our landscapes are so rock hard and concrete like it's a huge contributor to our flooding that we have here, because that water's just not being held in the landscape. I live up in a place called the Northern Rivers too, and it's a big reason we get some big floods up here as well. We've just done so much damage to the land here. And as you said, it's not just the rainwater harvesting we can do in our own communities, but how do we push for those policies to really incentivize and help farmers to change their practices, to create the soils that are able to hold those landscapes? There's a lot of work to do there, but maybe Anastasia, you can talk about, there's so many benefits from doing that, you know, from the biodiversity that kicks off. Can you just talk too about what happens when we hold more water in the landscape? What are the cascading benefits that come from that?
Yes, but I would also want to comment first on the floods, because and here we have the same positive feedback as with the biotic pump, but not controlled by the ecosystem, by the biota. Because when our planet is dominated by the ocean, right? So the continents are smaller, and Australia is a small continent. So there can be occasions when the dynamics of ocean atmosphere makes it such that their condensation does begin over Australia. And as it is like a self-enforcing process, more condensation brings more moisture, and there are no forests or no natural vegetation to generate small mild rains everywhere, not allowing it to make this explosive development. So so that's why such terrible atmospheric fluctuations and floods can happen. And when we, as Michal says, begin restoring biodiversity and ecosystems from the coast and going inland, and actually we will be repeating the path that terrestrial life followed when it first invaded land.
Beautiful.
Because it is how life came to the inner parts of the continents, bringing water with itself.
Yeah.
And so as we move, so we will have more uniform precipitation, because for example, in Papua New Guinea, the researchers were puzzled why there are so intense rains annually, but even when people do gardening, like natural gardening, on very rather steep slopes, there's no soil erosion. Why? Because all the rains come in the form of mild rains. It rains often, but without extremes. And so the ecosystem enjoys a lot of available water, and it flourishes, but no damage. And this is what we are going to have when we respectfully restore the vegetation.
Beautiful. And Mikhail, can you just talk how this applies to urban areas? Because I imagine it's the same. We've just created these concrete landscapes, the heat island effect.
Okay.
What can we do to capture water in our cities and revegetate our urban areas?
Yeah, and this circular graph is above is this. Please return again to the circular economy. Yeah, next. One. Okay, this. Thank you. And look about the system about with Jane Lambert, we created and wrote this global action plan for restoring of small water cycle and climate. And we presented on Boston in 2015 is this concept how to starting to whole model, and we know that it's for this implementation and to return water which are lost and to contribute to sea level rise. If you will stay on the continents, create more than 100 million new jobs, together with a lot of sequestration of carbon, with prevention to damage from natural disasters, with creation of water sources, with decreasing of production sensible, with increasing production of latent heat, together with decreasing of temperature 1 degrees, average global temperature. And this concept, it is extremely cheap. It is about only 1% from global GDP. It will be invest for this process, only one case. And its official climate narrative is oriented to decarbonization, and the result is about need to 5 to 20% from global GDP. And this is one. And this is just now is modern trend to speaking about cycle economy. And cycle economy, we are still speaking about cycling of waste. But we have problem to understand that some closed cycle system is small water cycle. And we need to reverse, because on the community, every community can to participate. If you have problem, I don't need to bring for you fish, but you need to create system for burning of water in your dry lands. And after that will be a lot of great solution which will be reverse whole system, because just now is this extremely dangerous global situation about growing of population and decreasing of water sources. This is about this conflict, because natural sources is completely dependent on the states of water on the nature. And I still have problem to understand why this water policy everywhere is still oriented to dry up of lands. And to support runoff away from rainwater. And it is gift from us, from God, and we need to return to the system. And it is, if we will be starting this process, will be have positive impact on the natural sources, human sources, financial sources, technological sources, info sources, and everybody can to be happy. And not in conflict like just now. And just now, for example, if you are looking on the Arabian territory, if you are looking at the trouble with desertification and a lot of heavy storms and damage, natural catastrophe, it's everywhere is growing, and we need to solve this. This is big challenge for all of us, and please, my friend from Australia, help for that. You have big challenge, big chance to bring some innovative solution for very fast to restore, because we have in Slovakia quite interesting knowledges from small project, but how is reverse dry lands to by harvest rainwater to a beautiful rich ecosystem with biomass production.
Well, it's the level of craziness in Australia is to a degree, Mikhail, where in that Murray-Darling Basin, which you talked about before, which the lifeblood of our entire country, that has had 750,000 wetlands removed, we're growing cotton and almonds in that place. Two of the most water-intensive crops, not even for our own production, to shift overseas, owned by Canadian super funds and other stories. But that's how mismanaged and out of sync we are. But can I just you've got some beautiful slides there around some of the examples of what you've seen in urban environments. Can you just talk us through some of these? Because I think they're very hopeful for people, particularly living in cities. And can you just describe how, again, this makes a huge difference to the temperatures?
Yeah, and it's if you are looking over Melbourne community or urban zones, it's completely dry, like this one. And it's look above is its heat. There is this growing of overheat, and for example, close to coastal is 24, but 5 kilometer inside in urban zone is this 20 degrees higher. And it's because it's all rainwater from urban zones by paving, asphalting, roofing is channelized to sea. And this is about problem to understand, and why we need to change of water policy and about responsibility, because it's if I am starting to develop some industry park or my house, I need to accept rainwater on my territory. This is public needs. And it just now is all public needs is strongly oriented how to distribute the water sources, but who will be prepare better condition. And public policy needs to be oriented to protect a reverse system of recycling of water on the system and to create conditions for every ownership of lands in forest, agriculture, and urban. And urban, for example, in Slovakia, we have only 5% from territory. It's small country in Central Europe, but impact on the desertification process is 27%. Forest, we have 441%, but damage, bad practices of forest have impact only 17%. And agricultural 51% of territory, and influence on the desertification is 56%, which means it is necessary to create a whole agriculture policy, forest policy, and urban policy need to be accept rainwater to harvest to the system. It's not only for like modern green fashion trend, but it is our needs and priority for climate system and climate security.
Can I just stick to the urban for a second, mate? Because again, obviously some of our major cities here, we're going to face all sorts of challenges with water in the future. Can you talk about how some cities are capturing the water? Because I know I've read a fair bit about China's sponge cities and how they're making these walkways that are porous now to catch the water in tanks, how they're putting wetlands back through their cities to catch as much water as possible. Can you just talk us through some of these images and what cities are starting to do to repair that cycle in these urban areas?
Yeah, and it's if you are looking on the first very nice flower on the top roofs, it is on the Seoul University in South Korea. And in South Korea is a beautiful, great guy. It is Myung-han, professor, which are starting to prepare this concept of a green roof, how to harvest rainwater and produce some food on the community level, which means every roof can to be completely green. It is one. Second is about to how to next slides, please, if you like. Yeah, this is another example from Oslo, and it's Bent Breskerud. It is famous guy which was water engineer too, and he was fascinated by new water paradigm and reverse system, for example, with dry niche system from community channel for transport of rainwater to completely reverse, and just now is this beautiful, very nice place. A lot of people very fascinated how to be live here, because water is close to you. It is beautiful place for not only for microclimate system but vegetation, but and very a lot of funny story are around this. Another it is about this is how to make vertical green facade. This is like this is very nice story from Czech Republic, from one ownership of parking industry territory, and he developed this concept how to make harvest of rainwater and to make this production of green facade, and it is a big challenge for all urban zones. This is about Spawn City on the China. And important is it is necessary starting to solve from cheap solution to expensive solutions, because it's to make only one experiment and to go to looking for million of people is nice for understanding, but we need to very fast to reverse whole system on the rainwater harvesting directly in urban zones and to make cool effect.
Fantastic.
This is from Oslo too, yeah. Look how to close to your house to flowing water. It is a very nice place, yeah.
You can see also so many benefits for pollinators to come back as well. There are just so many other great things that we can do in those urban areas.
Yeah.
We're going to go to some questions soon. So if anyone does have any questions, just chuck them in the chat and we'll get to them in about 10 minutes or so. But I wanted to end on a bit of a high here and just maybe both of you share. Anastasia, you can go first. What are some of the most hopeful or optimistic sort of water repair cycle stories that you've come across that are happening in the world right now or have happened? And you can include your own work, both of you as well. I'm sure there's some pretty stunning examples you've got. But yeah, what gives you the most hope that you've seen?
For me, I'm mostly concerned not about maybe restoration in the first place, but about preserving what we still have. So, of course, what's going on in world's major forests like the Amazon and Congo is very important, and we should keep an eye on that because it matters for us all. But regarding restoration, one of the last examples that I heard about that are really inspiring and show that this philosophy of respecting water is spreading was about the Mexico City. If I'm not mistaken, it was a very recent news that they decided to cancel a project of a large airport, like for many $1 billion, and allocated all this area for restoration of wetlands and developing a wetland there. So this is, of course, very inspiring and shows that people are changing in their attitude towards plants and water nexus, which is crucial for our existence.
Just before you move on there, Anastasia, can you talk to us about, I think, just how important the Amazon forest is to the earth in terms of that water cycle? I think from my understanding,
this is really crucial because the Amazon rainforest is located in the tropical zone near the equator, where we are receiving the largest amounts of solar energy. And if it is mismanaged, mismanaged by the surface, so to speak. The implications for global climate are huge, huge. And it relates namely to the various aspects of the water cycle. First of all, with clouds, and as I mentioned, in 2023, the Amazon low-level clouds that cool the Earth declined significantly. And so we do need this vegetation to be in a healthy state to avoid very drastic fluctuations of global and regional climates. And also what is important, this moisture transport from the Atlantic Ocean to the Amazon, it is a very large-scale process that that occurs over many thousands of kilometers. And so it also impacts the oceanic circulation and have long distance correlations and teleconnections with oceanic circulation. So basically it is a hot spot and a wet spot and a very crucial spot for our climate. So it is really of everybody's concern. While we are beginning to understand the importance of restoration, of ecological and eco-hydrological restoration, we absolutely must preserve what we still have. It is not, this forest is not damaged beyond repair. It is a mighty forest that has survived millions of years of evolution, which so many cataclysms, and it survived. So it is there. We just need to protect it from the direct elimination by burning, by logging. So that's what we need to do, and to begin to restore buffer zones across it. So that's crucially important for everyone living on Earth.
I know that a few years ago that somewhere the US government recognized it as a national security threat because of the rainfall contribution that the Amazon provided to one of their food bowls in California. So they sent a delegation over there to have a chat to the government there, because suddenly they realized that this was going to jeopardize their own future as well. So it sounds like that kind of awareness is growing at the right places, which is good. Let's see what happens now. Mikhail,
now there are plans to make a paved road to the heart of the Amazon, and this will have entail enormous destruction. So unfortunately, there are many nice declarations, but behind the scenes, there are attempts to grab this still favorable climates and to restore, to destroy it in the short term, to make profit from short-term agriculture, and this will have a very bad consequences. So if we can, we should stop it and try to stop it now.
It feels deeper, doesn't it? It feels like we've just, so many people see a tree as in kind of a reductionist lens, and it might be a bit of timber, or it's a resource, it's a stock, instead of understanding the deep importance of that tree for life, for water, as a living system, instead of seeing in this reductionist lens. And I feel like that's the only way we're going to get this stuff through, is to keep talking about this, how the interconnectedness of all these things work. Mikhail, we've got a little bit of time left. Can you just quickly give us some of your examples of where you're really inspired, and maybe share some of the work that you've done on your own landscapes? If you can just take us through that.
Yeah, and we developed some initiative in Slovakia about blue alternative. It's alternative to solving due to technocrat solutions about water dams. And after that, it's in Slovakia. We have a lot of different places which we develop, and one is about story from after windstorm in High Tatras, which are completely 12,000 hectares was destroyed, and my NGO people and water starting to mobilize on harvest of money, and we find a good sponsor from Slovak Saving Bank, and the result is this first step, which was to stop to run off rainwater away. And after planting, the result is just now it's very beautiful and completely reverse of whole system. And look above this picture after 15 years. It is one. Another, it is about next slides, if you please. We had in Košice, it is a small project, and this was starting after local community parliament. We decided to sign this Košice protocol for water, and from this was starting to build first project in 2005, and the results look above is completely dry lands, which have a lot of problem with small local floods in tennis court, and the result is how is vegetation is reverse after saving of rainwater only without nothing, which is project was completely cheap on the community solution, and everybody can to be, if you have your land is dry and you have one per year is massive rain, if you harvest this water, you can to reverse and to starting to create great condition for not only for biodiversity but for production something. It's one, and this model, it is good for community level, and in Sydney, in Melbourne, this is Oslo community, which create with this guy from Oslo community and so on. And we have in Europe, it's around with Marco Schmidt from Technical University in Berlin, create great possibility how to harvest rainwater on the top and create its small lakes. The underground is this parking place. It is how to is this very simple solution with creation better condition for walking on the community level and so on. Yeah, this is about this is a lot of possibility, but main important principle is starting to change of water policy from sectoral approach to protect only water which we only see on the holistical approach, and to starting to reverse what protect and to restore whole water cycle system everywhere, and every community can to be participate. Every farmers, foresters, water engineer, road infrastructure builders can to be support and to implement. But first, what is necessary to develop it is water law on the community level, regional level, and so on. Around our region, which is 7,000 square kilometer in Košice, we create whole system how it is possible to reverse and to harvest rainwater, and what is mean for carbon sequestration, water sources production, increasing of fertilizing and production of food production, together with decreasing of temperature 0.77 degrees average. And it's which mean it is example evidence system how to decreasing of temperature of planet Earth. Just now is hot discussion about how to decrease a very strong growing of global temperature before industrial zones time. And this is a big challenge for all of us. This is about China sponge cities, and China have a lot of trouble because it's a massive, huge growing of development, the same with India. But in India, maybe you know that it's not only with waterman Rajendra Singh from Rajasthan, but it's very nice project in Maharashtra. In Maharashtra, it was starting to develop on the community level on the case of water budget, and result is just now influence how to invite to farmers to manage of rainwater together with food production. It is about 1 million hectares of lands was reversed. This is about quite interesting challenge which is close to Australia people. It is they have water organization trust organized around 20 years and have very good condition with increasing water tables and reverse water, because it's after completely destroy of landscape was have a lot of problem and loss of not only water from the ecosystem, but lost water from the small water cycle and to loss of raining.
Very good. Thank you, Mikhail. I might just quickly, there's a couple of Australian examples here. So there's obviously some of you might know the Malone Institute and Peter Andrews' work. This is Tarwin Park as well. Sorry, that previous slide. And that's, again, his attempt to bring back the chain of ponds, that technique there, which you can see of how it used to exist on the landscape. And all the other farms around there are quite degraded and dry. And he's obviously changed the water pattern there. That's a really great example. On the next slide as well, the Malone Institute is a really good example of what the hard-hoofed animals and what's happened in the Australian landscape, many parts of our country, but how things can be brought back really quickly. I'm just going to go to some questions from the audience. There's quite a few here, so we might skip through them, everyone. We've got about 25 minutes left. So a lot of them are for both of you, so I'll just read them out. Anastasia, there's a question here for you from Shashi. Why is the biotic pump not included in global climate models coupling so far?
First of all, the global climate models have a limited capacity to reproduce the existing water cycle, so there are many deficiencies. And but the problem is that the feedbacks that are involved are very complex, and especially when natural ecosystems are involved with their complexity that is unmatched in the inanimate world. So it is just not technically feasible to include explicitly the biotic pump mechanism. So we need to rely on more general considerations, like on theory as to how to constrain model outputs. So we can't just rely on models.
Right. Thanks, Anastasia. There's a question here from Anthony Gleason. Are there any books or resources that you would recommend we check out? Obviously, The New Water Paradigm is a pretty good book from Mikhail, but any others that you two would recommend?
And we are just now, it's together with Anastasia and with another guys around the globe, we are writing in processing to write this new climate paradigm, because we need to deeply sharing of knowledges. And after 15 years of presented of new water paradigm, we have a lot of new arguments for why it is necessary to orient it interaction between water and climate system, because it's and we know that it's water we need for our drink. We know that water we need for food. We know that we water need for example, for beautiful landscape and for biodiversity. And just now it is from our knowledges about biopumping, about this interaction between states of water and thermoregulation of the system. We know that it's necessary to bring sharing these knowledges to another people. And for example, next week I am traveling to Spain, to explain about how to in urban zone to solve because we know that Valencia was catastrophic reality, and for future it is very danger. And for example, in July I wrote on the LinkedIn and post about this listen guy. It is extremely dangerous situation. On the autumn will be massive extreme disaster. And because it's this biopumping wave, it is radically changed from in summertime with heat bubble, it is make block to stop to flow of humid air from ocean territory, and after make dramatically decreasing of temperature of dry land, massive pumping of water from ocean and create danger situation, which means it is necessary to create a real good condition for restoring of nature, and people need to deeply understand a relation between states of water and what is mean it's 1 drop of water or 1 cubic meter of water for my life, for my climate system, for my food production, and for my biodiversity and social needs, of course.
Andrew Ling's just got a question here. Maybe Anastasia, you can take this. Do you have a feel for how much the current global temperature anomalies can be attributed to CO2 and how much can be attributed to deforestation?
Actually, this is a complicated issue because there are many factors involved. But we calculated that and estimated from theory. I can see a question that it's not feasible to if it's not feasible to model the biotic pump, how you are able to make predictions like -1 degree of average temperature mitigation. That's I'm reading the question, but you can show that the effect can be significant. So that's our bottom lines, that we show that the reduction in evapotranspiration that is associated with destruction of primary forests is enough to make a significant contribution to global warming. And we estimate that this could be like 1/2 of warming caused by loss of transpiration. And and another thing, if the models don't account for this, we need to point out to empirical evidence that supports the role of transpiration but contradicts the models. And such evidence is the trends in the lapse rate of air temperature. So remember what we discussed, that latent heat is transported to the upper levels in the atmosphere, and this makes the temperature difference smaller than in the absence of this transport, because there is heat here, okay? So if this effect diminishes, we will see that the lapse rate increases. It becomes steeper because more heat is now concentrated on the ground as sensible heat, and less is transported upward. And this is what is actually being observed. And this contradicts the prediction of global climate models that don't take this effect into account. And this is a known and recognized problem of mismatch between models and observations, to which we provide this explanation that this is due to reduction of transpiration. This is one thing. Another thing is that if we don't take it the change in transpiration into account, we can expect that global precipitation increases with global warming. And this is what models predict. Why is it so? Because transpiration is, if we just think about ocean and unlimited water, transpiration is ultimately limited by solar radiation. And solar radiation is increasing because albedo decreases and the less clouds, and so there is more and more solar energy coming. So this could lead to more transpiration and more precipitation as a consequence. And second thing, that when the temperature grows, the proportion, the Bowen ratio, so-called proportion between latent heat and sensible heat, changes in favor of latent heat. So two effects. But if we look actually at the global trend in precipitation in the last 40 years, and using the most recent, most well-developed GPCP data set, we can see that there is no increase in precipitation. And on the contrary, 2024 was an unprecedented anomaly, negative anomaly of precipitation over land. So we see something entirely different, which is consistent with the devastation of vegetation in major regions with major transpiration. So this is really why I see why the climate activists are not talking about that. That's a different story. But there are serious lines of evidence that support a major role of what happens with vegetation and the terrestrial water cycle in the global warming patterns that we are having. And yes, and the third point, which people should know, is that now it is officially recognized by the mainstream climate science that models can't explain the recent anomalous acceleration of warming. So there are unresolved questions, and there must be the answers must be found, and we are proposing such an answer.
Brilliant. Thank you. There's a question here. What effect is man-made chemicals being introduced into the water cycle having? I'm thinking of glyphosate. Is there already ways of reducing this happening in the world? Or I guess, yeah, or are these chemicals now entrenched in the water cycle? Do either of you have anything to say on that?
Yeah, it's if you are looking at water cycle about the system, and problem is about why it is a lot of misunderstanding understanding of the globe. It's that it's people which are oriented to develop this concept about finding of reason why is this global temperature is growing, and to find it is it's CO2 is growing, temperature is growing, which means clear correlation. But this concept was that it's forgot completely for small water cycle system. And for example, if you are looking on the curious graph of IPCC panel about reality of level of knowledge is what component have impact on the climate change. And high level of this is about CO2, and low level is about middle and low is aerosols. A low level is about albedos, and zero level is about water cycle, what is mean. And we were on the conference on the United Nations of New York, and General Chief of United Nations say, water cycle is broken. But it is one, it's about to understanding and how to involve in the system, because it's if you are looking in globally, what is mean in concrete, in local situation, and how to have influence and change this, and this climate model still forgot for dynamic process of change of human activity on the desertification process. And it's one. And second is about if you are looking on the calculation on what is mean about this impact of production of photosynthesis and biomass production due to stays of water on the nature. If we will be starting to harvest and to reverse water to the system, which was, for example, 50, 60 years before, we can to return to decreasing of CO2 from atmosphere about more than 50 billion tons. And we know that it's around 43 billion tons are influenced from industry, but we can do with CO2 we absorb to ecosystem and create better condition for our life, for biodiversity, for food production, and so on, for chemical and biological processing, because it's CO2 is growing over temperature, and its paradox is that its oxygen is twice more faster is decreasing on the atmosphere. And we need for our body and for our thinking good condition of oxygen in atmosphere. And this is about big challenge, how to a lot of misunderstanding about reality, but I am sure that it's global society on the community level starting to helping for local solution and to bring to global auditorium, look, this is concrete solution how to reverse system for climate, for food production, for biodiversity and social stability and local economy of the system.
But Mikhail, just to that question though, have you guys, either of you noticed, are there any interesting data about certain chemicals that are showing up in the water cycle now? You know, I've heard sort of anecdotally things about certain chemicals like glyphosate raining on different parts of the landscape. Is there, what sort of evidence have you got for those sort of numbers?
And it's I am speaking only about my knowledge and experience which I have. And it is necessary. The problem is that this global scientific community forgot to make a lot of research about this interaction between different parameters due to climate change.
Okay.
Uh,
There's a
If
sorry.
if I may, I would like to add to what Michael said also about CO2, that basically what is important also for oxygen breathing organism, not just the absolute amount of oxygen concentration, but also the ratio between CO2 and oxygen. And when CO2 is increases, it doesn't act well on our physiology. So this is a topic that is in the shadow, and this has no relevance to global warming, but CO2 can be also seen as a physiological pollutant for air breathing and especially mammals. So this is an important topic that some researchers are beginning to investigate. So it is not for without a reason that the biosphere was keeping that pre-industrial level for quite some time. So that we deviate from it, it is not good. So,
There's a question here from Michelle saying, heavy machinery used in agriculture compacts the soil, reduces water holding capacity, and contributes to flooding. Should we move away from mechanized agriculture?
Yeah, it is a good question, because it's I know that it's pressure of soil. It is danger for stabilization, but its ownership of farmer is responsible for states of absorb this water, which means it is necessary to find this mechanism which will be to motivate with all farmers to manage of water together with using of machinery. This is about problem about to, because we were very strongly oriented to massive industry policy, and just now, for example, in European territory is growing a lot of great initiative about regenerative farming. And this is about necessary to make this a society which bring concrete solution, but this is solution is oriented for local economy, for community needs. And we need to reverse whole system of economical model, how to decide it to harmony between economical needs, environmental needs, and climate and social needs.
Fantastic.
May also add to this that on the other hand, we need to understand that this mechanization of agriculture also had a reason, because it freed a lot of people from very hard labor on the ground. In our group, so I'm a theorist, but I spent a lot of time in wild nature, so I know what it means and how it's hard to live from nature when you and also agricultural labor is very hard. We have colleagues who are doing restoration work. And so when we say, let us move away from mechanized agriculture, this means that we should return to land, many more people, and begin working on land rather than sitting in front of computers and chatting with each other. And so the question is whether many people are ready to do that. So it's not easy, it is not cheap. It will reward us with healthier soil and cleaner waters, but it is a challenge. That's it.
Yeah.
So we need to be real.
Yes. Yeah. There's just before we finish, there's a couple of questions here. Just if one of you could just tease out a bit more this rise of atmospheric rivers, and just maybe just explain that. There's a link there, just talking about does someone want to?
Okay, I can do maybe my explanation on the due to new water paradigm, because it's production of sensible heat to troposphere created this networking of heat islands. And with heat islands, some big heat islands is, for example, it is on the Africa European territory, which is huge, massive, some biggest heat island. Another is about Australia, and in central part of in whole North America and so on. Just now it's starting growing in China, in Latin America and so on. And problem is about to understanding, because there is conflict between latent and sensible heat. And with networking of sensible heat production of bubble, starting to prepare, create this networking of quite unique clouds on the atmosphere, which are supported by flow of energy in atmosphere. And in coastal zone of Australia, you have sometimes per year is massive rolling of clouds. And this is results from conflict between ocean climate system and inside. And how to be prevent, which means it is to create this better condition for decreasing of sensible heat on the continent, and to decrease of flow of energy on the atmosphere. And after that, I think will be with clouds on the sky will be more diverse. And I explain on the, for example, in a couple of days before on the post on the LinkedIn about this conflict between reality, how was burning of atmospheric river on the boundary between cold zone and hot zone in United States territory. Sorry. And the same time on the Amazonia was more diverse. Because it's here is it's this rainforest is produce more latent heat, and this conflict which create with this cold zone from massive heat island prepare dangerous situation for pressing of clouds on the smaller plays on the atmosphere. And first time we explained this is a position on the small case in Slovakia 20 years ago.
Thank you, Mikhail. Thank you to you both for your extraordinary knowledge and expertise and how well you shared it today. Thank you. It's big stuff and it's new and it's complicated, but really appreciate you taking the time. I think to finish, do you just have I guess, a couple of quick words for people that do want to get more involved or want to wonder how they can help in their communities? They might not own a farm, they might live in a city. What would you both suggest people do to take meaningful action on this after we leave today? Anastasia?
Yes, but may I also answer the last question, which I see here about models, just as we have. Okay, can you give me 1 minute?
Go on.
So this is an important question because really we rely so much on global climate models, and the question is it that the models so far haven't modeled this, but they could be improved so it could be done? Actually, it is a challenge to model positive feedback, even if they are purely of physical nature. And currently, it is a recognition in the modeling community that the crucial feedbacks between condensation and air motion are missing in models. Even in the models with the highest resolution, which is about already 1 kilometer, global models, this feedback is missing. So whether it can be modeled or it can't be modeled is still an open question. And there is also a recognition that models and observations have been improving faster than our theoretical understanding of what's going on. So if we develop theory and more general considerations like the biotic pump proposes, it will guide our knowledge of also and how to develop meaningful strategies. And here I come to what Damon said, what I would suggest how people could participate. I do think that we need more global awareness and think comprehensively on what impact we are leaving on the planet as a whole. I do respect local approach and think that it is the beginning of everything, what we do to our land locally, but also we need to think what consequences it will have. So, for example, in my country, we have a lot of agriculture and we are selling wheat and it is produced unsustainably as everywhere else, big agriculture. But if we just stop it now and decide, let it be a nice wilderness there, first of all, the wilderness won't develop earlier than in many decades. But those people who are eating this wheat and using it right now, what will they eat? They will have to chop down the local forest, and so we will end up with even more destruction. So when we think of everything, we need to think comprehensively. And the best thing, which certainly will do good on any level, is when we restore productivity where it is now very low or zero, like dry lands, like what Michal says. If there is nothing and we restore the productivity, first of all, we improve local well-being for local people, for ourselves, and second, we lessen the impact. Since we grow something there, we lessen the impact on natural ecosystems everywhere, because there was nothing, but now there is something, and we can exploit them less. So this is what Michal's new water paradigm calls people for: improve what is mostly degraded. This is, I think, is absolute good in the current situation. Thank you.
It's some great, thank you, Anastasia. There's some beautiful examples too of people starting to not have food or nature be exclusively apart, and planting micro food forests in schools or on old abandoned tennis courts or in different parts of the city. So I think there is a way we can still produce food, but also create nature if we're really clever about creating those kind of integrated systems. Mikhail, do you want to just provide a bit of an action that people can take away with?
You are muted.
You're on mute.
Sorry. One level is about global, what say Anastasia about this strategic decision making on global, regional, national level and so on. But important is to understand and to mobilize people, because it's narrative. It is still just now that it's I am ordinary guy. I have how I can help for climate. And with solution, and we calculate that, for example, globally, from our knowledge is that it's annually lost from continent 700 cube kilometer of rainwater contribute to sea level rise. It is 2.1 millimeter of sea level rise, which mean global society is about 8 billion citizen, which means for one citizen is about 100 cubic meter of water sources. But with water sources, every from us and globally, it is job for 1 week creation water retention measures for harvest of 100 cubic meter is no necessary money for that. If you have garden, I have a house, I can harvest my water from my roof to my garden. And it is necessary to create global movement, because we cannot wait for what we are waiting for global crisis. We need to starting to very fast to reverse, because its problem is about to have is very fast degradation from year to year is growing of temperature and growing and so on. And with make cool effect, it will be create, for example, million people on the community level, like this rainwater harvesting, water management system and change, which is about change of water paradigm, starting to people on the politician level starting to oh, it is quite interesting movement. I can to support, and I will support that. Because we need to create pressure for solutions, and with this great chance for all of us. Because if I am looking for my grandkids, that it is I am still thinking how is dangerous situation is for 10 years, not 20. It is maybe in my life will be completely on the collapse. And we need to help for that. Please, friends from Australia, you have big chance to bring new global solutions.
Brilliant. Thank you both so very much. Thank you to Bryony, David, everyone for organising this terrific event. I think what you said, Mikhail, earlier was that to not see rain as waste, but to see it as a gift. It really is a gift, and it's the very seed and basics of all life. And we do need to value it and look at it in a very different way. So thank you everyone who sat and spent their Saturday with us today. I hope you took away some really valuable messages, and it is up to all of us to go and spread this, share it, and make sure that more and more people understand how important water really is. So thanks again for joining us, and take care.
Thank you.
Thank you.